For a century, the penalty kick was a biological lottery. Goalkeepers relied on instinct and physics, reacting to a ball traveling at 70 miles per hour with little more than a desperate guess. This chart shows historical penalty save percentages. Notice how the line stays flat for decades. Then, in the 2026 World Cup, the save rate spiked by 40%. That vertical leap is the result of specialized hardware. Goalkeepers are now stepping onto the pitch wearing smart contact lenses that project an augmented ocular overlay directly onto their retinas. These lenses track the ball's rotation speed in real time. By reading that spin, the software predicts trajectory deviations and feeds them into the keeper's field of vision before the ball crosses the line. The sport has transitioned into a defined period of data-driven anticipatory reaction. The process starts during the long walk to the penalty spot. From the goalkeeper's perspective, a stadium is a chaotic visual environment of blinding lights and thousands of moving fans. Inside the smart lens, inward-facing biometric sensors immediately go to work. They monitor the goalkeeper's own pupil dilation to establish a stable baseline. Simultaneously, the outward-facing software kicks in. It filters out stadium strobe lights and erratic crowd movement, artificially darkening the periphery to isolate the striker's plant foot. This animated map represents the goalkeeper's incoming data stream. As the striker approaches the box, the lens syncs with historical databases, populating the target footprint with a cascading series of nodes that map out past shot locations for this specific player. Before the ball is even placed on the grass, the goalkeeper is already looking at a statistical map of the striker's tendencies. In the silence before the whistle, the striker looks into an eye that is actively processing their history. That glowing ring around the iris represents a library of data the kicker can neither see nor influence. While the kicker's heart rate climbs, the keeper remains calm. A biological feedback loop within the lens interface regulates their stress response based on the real-time vitals it collects. On the other side of the ball, the striker realizes that every biometric twitch, shoulder dip, and breathing pattern is being captured and processed by the goalkeeper's hardware. The penalty box has become an arena where one player sees the internal mechanics of the other, tilting the balance of the encounter toward the goal line. The striker begins their run. Instantly, the lens identifies micro-gestures in the player's movement, tiny shifts in muscle tension that are invisible to the naked eye. This vector representation calculates strike point probability. Neon lines intersecting at the pelvis measure hip rotation. Correlating that angle with historical data eliminates false trajectories. Just before impact, the augmented overlay projects a single vector line onto the retina, predicting the exact ball path. By the time the striker's boot makes contact, the goalkeeper has already initiated their dive toward the high-probability intercept point, turning a split-second reaction into a calculated maneuver. This technology has sparked intense scrutiny over the rulebook. Current FIFA regulations have classified this sensory enhancement as legal protective eyewear, allowing it onto the pitch. That ruling has fractured the sports community, igniting a debate between biological naturalists who want to preserve human ability and advocates pushing the limits of the human body. The scale of this hardware is expanding. This World Cup experiment is expected to trickle down to every professional league by 2027. But athletes adapt. Strikers are already studying ways to counter the lens by practicing false biometric tells and adopting intentionally deceptive hip angles during their run-ups. Has the art of the penalty kick been permanently solved by machines, or has this just sparked a new, invisible biological arms race?